Wait, Tanya, I think you're muted.
Okay, wait, never mind. I accidentally had the sound on for my slideshow instead. So I'll start over. Okay, I think you guys heard everything that I said before I started sharing, right? Okay, so I'll just start. So we're gonna do like everything that builds up to chemical reactions, including atomic structure and the periodic table and stuff like that, and bonds. So all matter is made up of atoms. So everything you interact with on a day-to-day basis has mass, and everything that has mass is matter. Atoms have protons, neutrons, and electrons inside. So the protons and the neutrons, they're like bound together in the nucleus, and the electrons are just orbiting. So protons have a charge of +1, neutrons have a charge of 0, and electrons have a charge of -1. Protons and neutrons have mass, so they're one atomic mass unit. So 1 mole of protons weighs approximately 1 gram. But electrons are basically weightless, so we just ignore their weight. So the periodic table is a way that we can sort all of the different elements. An element is something that has only one proton, only one number of protons in it. So all hydrogen atoms have 1 proton in them, and all helium atoms have 2. The proton is the defining feature of what makes an element that element. So the periodic table is sorted accordingly based off of the number of protons, but as you can see, it's not just like a regular rectangle. It's a weird shaped rectangle with stuff in it. So, and that's because it's sorted by the number of valence electrons as well. So we just talked about electrons, and I didn't mention that electrons, for our purposes, basically orbit in orbitals or shells just around them. And the inner shells will almost always be completely full, but the outer shell is the valence shell. And that's what's really important because that's what gives it its properties and how it tells you how it bonds. So in row 1, it has 1 valence electron. Row 2, it has 2 valence electrons. And then we skip this red section because that's the d orbital, and that's a little bit more complicated. But the 13th row column has 3 protons, has 3 electrons in it, sorry. And 1 shell can hold 8 electrons. So each atom wants to be neutral in charge, but it also wants to have a full shell of valence electrons. So it will gain or lose electrons in order to meet its needs, essentially. And the rightmost column here is the most important column. It's the noble gases. It has a full shell of valence electrons, so it has 8. So the columns are called groups because they have similar properties, and the rows are called periods. So moles, which will feature a lot in chemistry, especially as you do calculations and like get into the laboratory stuff, moles are just a unit of measure. So 1 mole is approximately 6.022 times 10 to the 23rd atoms or molecules or whatever you have. So 1 mole of an element is the same as its atomic mass, which is really important because it can help you determine how much something weighs. So if you look back at the periodic table, the mass is the number below the name right here. And the mass is just the average weight of all of those all of the atoms of each element. So here, if you have 1 mole of oxygen, that would weigh approximately 15.999 grams. Octet rule, I did talk about this a little bit. All atoms want to have the electron configuration as their closest noble gas. So on the rightmost columns, they want to gain electrons so that they can get to that 8. So if an atom like fluorine has 7 valence electrons, it's really going to want 1 more to complete its shell. But if an atom like sodium, it only has a 1 valence electron. So it's going to try to lose that electron so it can become like the closest noble gas and have a full cell. So there are multiple ways that an atom could try to obtain this electron configuration. So a molecule is 2 atoms bonded together. Covalent molecules, they share electrons. So as you can see in the diagram on the right side, hydrogen and oxygen, they will try to share the electrons so that they both have a full shell. Like if you see oxygen, before it only had 6, but now it has 8. And hydrogen, before it only had 1, now it has 2. Hydrogen is kind of an exception to the octet rule because it's in the first group, it's in the first period, it has very little protons and neutrons. So the most it can get is 2. But ionic bonds, they just like to steal electrons because when you're on the very right side or the very left side, you're really, really close to getting that octet. So they'll just steal electrons from each other and then they become ions. And ions are just like things that have a charge. They're not neutral like most atoms by themselves are. So the sodium atom will lose an electron and the chlorine atom will gain an electron. But then they're not neutrally charged anymore. They have a charge because now the sodium atom has a 1 more proton than it has electrons, and the chlorine atom has a 1 fewer proton than it has electrons. So since sodium is now the positively charged and chlorine is now negatively charged, they will be attracted to each other since opposite charges will attract. Chemical reactions. So chemical reactions are just creating and breaking bonds. And an important thing to remember is that all matter is conserved. You cannot have 3 oxygen molecules on one side and then only have 2 on the right side. You have to balance them to make sure that the number of each element stays consistent throughout, because matter cannot be created or destroyed. Like here, we have 1 methane molecule, which is CH4, and 2 oxygen molecules, which is O2. And then they collide into each other in the right orientation, and they will pop off. They're just switch. And it creates 1 molecule of carbon dioxide or CO2 and 2 water molecules or H2O. So when methane has a 1 carbon and 4 hydrogen, oxygen has 2 oxygens, and carbon dioxide has 1 carbon and 2 oxygens. Water has 2 hydrogens and 1 oxygen. But that's not balanced yet. So you just have to play around with it and just add the coefficients to change it. So I haven't explained how this notation works yet, but essentially if there's a subscript or the smaller number that means there are 4 of those in the molecule. So a methane has 4 hydrogen. But if the number is in the front, that's the coefficient. So that means there are 2 of that molecule. So it's 2 oxygen molecules. And what I recommend when you're practicing balancing equations is always balance the smaller or the one that only has 1 element last. So CH4, that has multiple elements in it, but O2 only has 1. So you can control it better, I guess. After you fix all the other ones, you can just fix the oxygen to make sure that they're balanced. And that was actually a very important reaction because that was a combustion reaction. A combustion reaction is when a hydrocarbon plus oxygen creates carbon dioxide in the water. This is better known as fire. And it releases a lot of heat in the process, but it also needs a little heat to get started. And a hydrocarbon is any molecule that only has hydrogen and carbon. Although a lot of other things can also burn, they won't burn as cleanly. Like they create byproducts, like maybe a little bit of carbon monoxide. Those are all the chemistry concepts that we're going to learn today. And I know I just went through them really, really fast. So if you guys have like any questions or anything, like feel free to like leave them in the Q&A. Okay. You guys can also do that after the thing. So we're also going to go over some more examples in real life, especially relating to food, because I like food. So antioxidants. You hear a lot about them everywhere. They're just like, eat blueberries, they have antioxidants inside. But how do these even work? So in your body, there probably are going to be a few free radicals just flying around. And a free radical is an atom, molecule, ion that has at least 1 unpaired valence electron. So this is pretty dangerous because it's not paired together. So the valence electron, it's very prone to like reacting with stuff, and it can just like mess with other stuff in your body, which is bad and like can cause cancer and stuff. So the antioxidant fixes that by neutralizing the free radical. It donates an electron. So now that unpaired valence electron is in a pair. So it's no longer dangerous. That's just a visual for what is happening. Oxidation. It's like when you cut your apple open and then at lunch it's brown. So polyphenol oxidase, it just rapidly oxidizes the enzymes inside to O-quinones. And oxidation is the losing of electrons. It's really stupidly named. O-quinones, and then those produce the brown color. Caramelization is when sugars break down when heated, and it's super complex and there are hundreds of reactions, but there are 3 main products that create the brown color that we know. Caramelins, and caramelines, or I don't know. So depending on the temperature that you heat it to, it will caramelize based off of the type of sugar. The Maillard reaction is when sugars and protein react to produce glycosylamine, and glycosylamine isomerizes to create ketosilamine. So an isomer is just something that has the same atoms and elements and the same number of each element, but it is oriented or like built in a different way. So the structure is fundamentally different. And those give food the brown color. Okay. Are there any questions before I do the practice questions that I made? If you put a wire over a tomato, will it turn brown? Okay, I've never tried this before, so like, what is the wire doing? I'm assuming, I've never tried, but I'm assuming that if it oxidizes it, it will also turn brown. I've thought of a couple things that I missed, so I'm gonna go over them really quickly. Sorry. Okay, so in the periodic table, there are different trends. So they will have different properties based off of where they are in the periodic table, but we're not going to talk about that today. Essentially, they have an atomic number, which is the same as the number of protons, the symbol, which if you take a chemistry class, you will probably need to memorize at least like the first couple of symbols, the name, and the atomic weight. So since the reason why it's not just integer values is that they have different isotopes. So like not all hydrogens have a 1 proton. Some of them have a 1 proton and 1 neutron, and that's called deuterium. Some of them have 1 proton and 2 neutrons, and that's called tritium, I think. So they will have different atomic weights, but for the most part, the properties are the same because the number of protons and electrons stay the same. And the number of electrons an atom has is dictated by the number of protons it has. So in its natural state, natural, but like in its by itself, oxygen will have 8 electrons in total. And fluorine would have 9 electrons in total. Moles, I have to emphasize this more. Moles are incredibly important when going through things. You will use them constantly, and it's really important to be able to convert between different units in chemistry. So the atomic masses, they're in grams per mole. So moles on the bottom. So if you have 2 moles, then you can multiply that by the atomic mass and then you'll get the weight because the moles cancel out on each side. So you just need to remember that the atomic mass is in grams per mole, and then you need to make sure that you're multiplying or dividing correctly so that whichever unit you want to be canceled out cancels out. Octet Rule. Okay, I think I covered this right, but it's complicated. Ignore the polar part, we'll get to that in a later one. Yeah, I think I went over this adequately. Okay, this lesson does not have that much stuff. So since nobody has any questions, we will do the practice problems that I got. These are pretty simple, so they're not going to be that challenging. You don't need to type it in the chat, you can just think of it in your mind. Which of these are not parts of an atom? Yeah, a compound is just multiple things smushed together. It's not one atom. It's definitely not inside of an atom. Which of these can happen? These don't always happen, but they can. Yes. Okay. Products and reactants should have the same mass. This is a very important concept. Yeah, true. They should have the same mass. Now, what charge does an electron have? Yes, it should have a -1. Okay, so I went over that really fast and you guys seem to get it. You guys probably already have a strong basis in the subject. So I'm going to answer a couple of questions and then I'm going to do some more stuff that I have not planned, but hopefully will go well. Question 4. Yeah, sorry. Which of the following Question 4 is which of the following has an unpaired electron which can cause harm? So this one is a free radical. So let me just explain why all of the other ones are wrong first. So an antioxidant, they don't cause harm, they repair the harm by donating the electron to neutralize the free radical. Free radicals, they have one pair, it's like one valence electron that's unpaired. So then it can react with a lot of things and that's not good. That can like cause cancer and stuff. Lactose is just a type of sugar. It's found in milk. And combustion, we already talked about that. It's a type of chemical reaction. Yes, I'm going to share my screen. Okay. So I went over that really fast and you guys caught on really quickly. So I'm just going to do some other stuff now. There are 4 main types of chemical reactions. And we're going to do these now. So a synthesis reaction is when two different molecules or atoms come together to make one larger molecule. Decomposition is the exact opposite, where they break apart. Single displacement, it's like one of them switch. They're usually ionic compounds, so they like break apart and then they switch. And double replacement is the same except for both of them switch. And that can be like pretty hard to just understand without knowing any examples. So I'm gonna find some examples. Okay, so synthesis, these are all examples of synthesis. They're just coming together and at the end, there will only be one product. I think that's pretty simple. decomposition is also pretty simple, like salt when it's dissolving in water. And the chlorine ion and the sodium ion, they're just big apart. They're just ions. Okay, I think the most hard to identify will definitely be the displacement reactions. So okay, like this one. Silver nitride and sodium chloride. This is a double replacement reaction because the silver is going to end up with the chloride at the end, and the sodium is going to be with the nitrogen. So they just switched. They just had to switch over. Okay, I think this is also going to be really important. So when you find the mass of 1 mole of a compound, it's just the masses of each one of the atoms added together. So, for example, water, H2O, that's 2 hydrogens and 1 oxygen. So it's like basically 16 plus 1 plus 1, which is 18. Or if you're going to do an oxygen molecule, which is 2 oxygens in it, that's 16 plus 16. So that's how you find the mass. We're not going to do sig figs because they bore me. Okay, this is important. So if you see an isotope in chemistry, they will have most likely be shown in this format. So on the top number, that's A, that's the mass number. The mass number is the number of protons and the number of neutrons added together. Z is the atomic number, which is the number of protons, and X is the chemical symbol for the elements. So if it's sodium, it'd be Na. If it's potassium, it'd be K, something like that. And today we learned the Bohr model, but it's very important to understand that that's not the most accurate way of viewing an atom anymore. So we've gone through many models as our technology and our discoveries have progressed. And now we think that is the quantum model, where they have different orbitals, but we're not going to talk about that right now. Okay. We still have time to burn, so I'm going to talk about this. Nuclear chemistry. So things can decay a lot through these forces. Okay, but not everything is just gonna randomly decay. That'd be really scary. So for atoms that are larger than 20, that have a Z of larger than 20, the ideal ratio is 1.5. The M to Z ratio is 1.5. So, but if the atomic number is greater than 83, all nuclear and unstable. When they're unstable, they will decay in various ways. An alpha decay is when an alpha particle leaves. Alpha particle is just 2 protons and 2 neutrons. The helium nucleus just leaves. So then it will create a helium nucleus and a new element. Beta decay is when a neutron emits an electron and the neutron becomes a proton. It's really weird. So the mass will stay the same, but the number of protons will not. And it will also emit an electron. Positron emission is when a proton releases a positron, which is kind of like an electron, but it's positive, and then it becomes a neutron. So the mass number is still going to stay the same, but again, the atomic number will change. It will decay by 1. And then gamma decay, it's just going to reconfigure it and release a ray that is very powerful. But nothing really changes. It's just more stable after it released the energy. And at any given moment, there will probably be some probability of decay. But it's impossible to determine for one atom when it will decay. You can't watch an atom and be like, ooh, it's going to decay right now. Like, that's not going to work. But you can know how much time it takes for half the sample to decay. And that's called a half-time. Not half-life. And that's the amount of time it takes for half the sample to decay. Okay. Do you guys have any questions? No, okay. I am going to do covalent bonds in more in-depth detail. I'm sorry again. Okay. I'm sorry, guys. I forget that when I share my screen, it mutes me for some reason. Okay, so more stuff about covalent bonding since we still have a lot more time. You might have to name compounds in future classes that you take. I know we have naming quizzes at my school. So first, you take the element that's on the bottom or the left side of the periodic table, and that's the first one. And then you take the element that's to the right or to the top of the periodic table, and that's the next one in the compound. So in the compound, you have those in order. And then you have to add the prefixes based off of the number of atoms of each element. So this would be di, tri, something like that, depending on the number of there. So in this case, it's dinitrogen and trioxide. And for the one at the end, we just add "ide" to the root, just so you know that it's in a bond. Covalent bonding is the sharing of electrons in order to follow the Octet Rule. We already talked about that. But we did not talk about how there might be polar or non-polar molecules. So, covalent bonding, they usually will not have that high of an electronegativity difference. Those are usually ionic bonds. But electronegativity is when an atom, when it's in a bond, how likely it is to attract all of those electrons to itself. So, and the trend is as you go to the right and as you go to the top, the more electronegativity is. So if you take water, for example, H2O, that means when it's in that bond, the oxygen will attract and hog most of those electrons, and they will not be orbiting around hydrogen as often. So what happens is that there will usually be a partial negative charge next to the oxygen and a partial positive charge next to the hydrogen. But not all bonds are polar. Some bonds, like O2, it's just oxygen and oxygen. So there's no electronegativity difference there. It's the same. And electronegativity can be measured in a number of ways, but one of the most common is the Pauling scale. Yeah, it would be called dihydrogen monoxide, but we mostly just call it water. And that actually reminds me, one time, a bunch of people just like stopped the dihydrogen monoxide from plaguing our town. And then they tried to ban it, but it was actually just water, and people acted like idiots. Not gonna do that. Okay, do you guys want to do sigma and pi bonds and hybridization? Because that is pretty complicated, but it's also pretty cool. Okay, we have nothing else to do really, so I'm just gonna do it. Okay, so depending on the different types of orbitals, there will be sigma and pi bonds. We haven't talked about this, but like I said, the Bohr model is not the most accurate model of an atom. And we now believe that there are like different shapes of the electron orbitals. depending on the energy level and stuff. So some of them are just circular shaped, and other of them are like dumbbell, sorry, or bow tie shaped. I think bow tie is more accurate, and they'll like overlap in different ways based off of that. So a pi bond is when they directly overlap, and then a sigma bond is like when they're like aligned and stuff. But it's usually a sigma bond if it's just a single bond. But if it's a double or triple bond, there will be pi bonds in there. So double bond is like there might be one bond between two different atoms, but lots of times there are two or three, depending on the number of electrons that they have. Sigma bonds or lateral overlap. Sigma bonds or overlap. Pi bonds are just lateral. Okay. Okay. Sorry guys, I went probably way too fast and then I was really scattered, but I will be happy to answer any of your questions right now. And if you don't, you could probably get off a couple of minutes early, or I can do a couple of problems with you that I made. So just like feel free to type in any questions that you have. Okay. So we are going to do some practice problems because in order to truly understand that, you really need to reinforce your knowledge with the problems. How much does 1 mole of zinc weigh? Remember that the atomic number is just that the atomic mass is just the amount of mass 1 mole of that thing takes up. So we just look at the zinc, or in this case, we go to this website. And on the periodic table, we see that zinc has an atomic mass of 65.38. So that means 1 mole of zinc weighs 65.38 grams. Okay. If an atom has 13 protons, 14 neutrons, and 10 electrons, what is the element and its charge? So, okay, yeah. Your question is, when molecules combine, how do they specifically arrange themselves in that specific way? Okay, so if it's a metal and a non-metal, that's probably an ionic bond. So for ionic bonds, you just need to make sure that the charges are balanced. So everything in the first row will usually have a +1 charge because it will lose that electron to become a full octet. But on the rightmost side, it will gain those electrons, so it will have a negative charge. So everything in the halogens group will usually have a -1 charge, and everything in group 16 will usually have a -2 charge. So let's see, have sodium and chlorine. Sodium is in the leftmost group, it's +1. Chlorine's in the rightmost one, other than the noble gases, because they don't count. So chlorine has a -1 charge. When you add them together, they balance out perfectly. But if you're going to do calcium and chlorine, well, then that'd be different because calcium is in the second group, so it has a +2 charge. Chlorine still has a -1 charge. So you have to get 2 of the chlorines in order to get in order to balance the charge of 1 calcium, because atoms want to be neutral. And if it's covalent bond, you'd probably just draw out the Lewis structure, and then you'd have to figure out the bonds from the Lewis structure, I think. And you're correct that it's Al +3, because the protons is what makes that element. So it's aluminum. The neutron doesn't really matter in this case, in the charge is +13 minus 10, which is +3. How much does 2 moles of water weigh? So 1 mole of water is just the atomic masses of all of those elements. So that's basically 1 + 1 + 16, since there are 2 hydrogens and 1 oxygen. That adds up to 18. But since you're asking for 2 moles, that would be 18 times 2, which is 36. So basically 36 grams. Balance the chemical reaction. This one should take a while, but you guys can figure it out. Okay, I haven't checked this one yet. So looking here. 4 atomic zones. I haven't checked this question, but if the number of each element is the same on both sides, then you got it. And it is a combustion reaction because you can tell from the products, which is CO2 and H2O. Okay, Octet Rule is when they want to have the same electron configuration as the closest noble gas. So they want that 4 valence shell, which is usually 8. Protons, the products or reactants should be the same, unless there's like a mistake in which it just escaped, because matter cannot be created nor destroyed, so it has to have the same mass in both sides. Water noble gases cool because they have a 4 valence shell, so they already have what basically all the other elements want. And describe the difference between ionic and covalent bonds. Ionic bonds, they just straight up steal the electrons, and then because they're ions now, they have a charge, they just attract each other. But covalent bonds, they share the electrons. And the bonus one, I'd be really impressed if you got this. But I can walk you through the process. So first you would have to balance the equation. And you need to find out how many moles of copper you have. And the balance equation tells you the ratios of the moles. So depending on the balance equation, you can multiply or divide to get the number of moles of nitrogen oxide. And then you need to multiply the number of moles of nitrogen oxide by the molecular mass of nitrogen dioxide. But you guys can do that at home. Okay. I know that was probably really confusing, but I'm gonna add more stuff next time so I don't jump around. And I'm also gonna practice next time. And I believe the next class should be forensics. So you guys can look forward to that because forensics is a lot of fun.